and I'm got a group me also started, and I'll share that in the chat also how to log on to that.
Yeah. Hello, everyone. Good evening. This is the first session of the OPIS 3 MWU and also OPIS 1 and 2. This first week, we're going to introduce John and we're going to introduce the basic tools that we have on this program and sessions, uh, just orientation and introductory level. And then by the next week, hopefully we catch the first lab and the activities and learn more on the first modules of the program accordingly. This course is divided by two main category. Opus 1 is they call it or place in space 1, 2, 3. Opus 1 is mainly focused on the nearby object on the sky, like or Earth, Moon, solar system, planets, and nearby celestial objects. And then Opus 2 gonna be go further, like nearby galaxies and star clusters and many others. And these Opus 1 and 2 mainly is visual observation and taking the picture from the celestial object on visual field of the spectrum. But on the Opus 3, we're going to tackle the radio wave part of the spectrum, electromagnetic spectrum of the celestial object, the object that is active on the radio. And we're going to take some measurements actually directly from the radio telescopes that are available for the course. And in addition of that, we're going to tackle the MWU. OPIS itself, OPIS 1, 2, 3, is black and white astronomy. It means that whatever pictures that we're going to take, either the planets or galaxies or star clusters or nebulas, all of them going to be very black and white, colorful, no color, only black and white. And for the Opus 3 is radio and Opus 1 and 2 is visual. But all of them is going to be black and white. We don't have any color. On MWU, we're going to use the tools that is available on the Skynet University that we're going to describe what is that to add some color to the picture that we're taking black and white. But they already, the picture that is taking on the FITS file, flexible, I think uh, I don't know the abbreviation. It's not top of my head, but something flexible, interactive file system that gather all the data, including the black and white and the different colors that comes from the filters and object. And then on the MWU, we're gonna use the tools that we have on the internet online programs that add some color to the picture. Keep in mind that these colors and also the object that we are going to take, that's only uh, actually identify the actual post-processing of the astrophotography. Therefore, as you go OPIS and MWU, you learn some tricks also in astrophotography, and that's very cool that if you have a tool in your home or your kind of other friends may have tools, you want to take a picture, you can use that kind of techniques to provide colorful pictures as well, based on the activity and tools we learn. Okay, I'm just talking less and just start to sharing. Before sharing, do you want to add something on it, John?
Yeah, sure can. So I put in the on the side the group me link to join on there, and I'll try to keep announcements in there. And also I'll try to create a Google Doc where we can share information. Also add that on. And part of the course where amazingly most of this is offset for the cost, the Skynet and the Astromancer, and even all the curriculum from that we're working with Dr. Reinhardt's amazing system here. there is a cost to get into the system, which is Cengage, which manages everything. So that's something this week we'll want to make sure happens, that you get into the system and get logged in and find the courses so you get all the resources, which includes, access to the videos and all the materials to help us really understand it. And there's a lot of pieces. So I keep a notebook with me and I'm always taking notes as we go through this. I encourage you to do the same. There's nothing else to help you know which week to go back to. And there'll be some things we'll use that'll be really quick resources. It might be things like exposure times or different addresses or processes on how to get to your different files. So a lot of us are very digital, but I would say don't hold everything up in your head. Put it on paper so that you won't have to think so much about it. You can look it up quickly and get to it. Um, and the nice addition this fall is going through the multi-wavelength study is realize that we see with our eyes just a small part of the spectrum. And we're kind of limited to that because we are on the Earth and our atmosphere blocks, as we'll find, so much of the light that would come through, which is kind of a good thing because we know Venus has a runaway greenhouse effect, and we don't have that, thankfully. And UV would cause cancers and other problems to happen. We don't have that either. So our atmosphere is just designed so that the light coming through is very visible and also in the radio. And we can, from the ground, build detectors which work real well with the radio. And our eyeballs and with optical detectors, we can see very much the visual. Now, to get the other, to see all that other spectrum that's missing, that's where we need special locations and special type of instruments, such as space telescopes and telescopes way up on mountains that are cutting through that atmosphere that can peer into the infrared and into the UV and strategically located in places around the world. So we have good viewing. That's part of the problem. With us is quite often our skies are often cloudy. We need some place where people can see, and we get past all this. So these images coming in, astronomers will talk with those as being data, and that's what we're doing. So if we're talking about processing data, for you, you might seem like we're just processing pictures. But when you start to put in the different wavelengths and the stuff we can't see, all of a sudden you see stuff there that you didn't know was there. Oh, there's all this glowing dust around it. There's nebulosity. There's I'd say ice, but there's different. I gotta be careful what I say. More like gases. And we can't even say gases because they're so diffuse. But we have things that maybe want to become stars, want to become part of a nebulosity. Maybe want to, or maybe we have high energies like stuff coming off of quasars and black holes and things like that. That we can see things outside our spectrum. It gets very interesting. And so part of the process will be learning how to use tools to layer these images, put some visible and are visible with the invisible to tell a story. And that's kind of an exciting part of this, I think, with the multi-wavelength. For the other one, it really is neat to use telescopes to learn astronomy, and that's what we'll be doing. So be ready for a little bit of processes, learning how to control equipment, how to put in the filters at the right settings, how to access telescopes in different places, and which ones do you want to access, which ones do not want to access, and how do you set the different settings. That's the stuff you just don't know. You need some help with, and that's what this course will help make happen.
Thank you, John. And do you have any question, Rohan, so far?
No, none so far.
Thank you. Then let me um, share the screen that uh, for the items that we're gonna tackle.
If you see me looking up a lot, it's because I have two screens going on. So Ron, that's what's going on there. I'm just trying to monitor both.
Got it.
Thank you. Yeah, this the main the basic tools that we have. You don't need it to have any. Everybody gonna use it online. It means that you don't need it to download anything. Everything is online and there's a cloud system. And whenever you have a chance to log in on the system, you're gonna access to those. And it might be on the first week or two, you may have some trouble to log in, but we're gonna help you out with John with the University of the North Carolina that is handling these activities and set up to make sure that everybody on the course has uh, able to log in and has a password and their own password and do the activity as well. The first part is they call it Cygnus here. It is Cygnus.com that is providing the course. Normally, if you wanna, for example, in here, you have to go first WebAssign. You have to Google it in here as I showed from the first place. You just said WebAssign login. And when you do WebAssign login, it comes here, WebAssign, flexible online learning STEM for the STEM courses. This includes everything. There is many courses, including astronomy. And here, the one that you have to log in, and I already log in here, but we're gonna go, you have to do the same thing, log in and create a password. And then when you log in, you enter the main course of the session. Here is my name is here, but it's gonna be your name in here. And here, my home or my library. And here, this is a courses that your course is gonna be identified here. And therefore, for example, this one, our primary instructor is Professor Dan Reinhardt, from the University of the Chapel Hill. And John and I, we are secondary and the teaching assistant that helping Dan on this. Therefore, this course is going to be available, any of them that you're going to open. When you open, I'm going to show it to you, just overall insight, what is included. Here, you see a list of the lab. Each, some of them, it takes 1 week or 2 weeks. Some of them, just a portion of the week. But on the OPIS1, we're going to go lab 1, lab 2. Lab 2, we have 2 options. We're going to go what the difference on that, but we're going to go with the Stellarium. One program that you needed to download is a Stellarium that you have to put it, I think, Stellarium. If you put it, there is this software. You can have option to logging on different system, Linux, Mac, and Windows, and the web. Web is that online you have access. You don't download. But I recommend to download it on your computer. Only program that you needed to download that has more features than the online and more flexibility. Therefore, either based on your system is Windows 7 plus or 10 plus 64 byte, you can either of them you click and download as well, and then you go forward with that. And right now I downloaded here, as you see it. We're gonna go later on how we're gonna set up that and different icon, what that means. And during the course, we're gonna learn each of them. We don't want to tackle all of them, but few basics of them that we needed to get the data from observation on the sky that we needed. Therefore, the main course labs gonna be on here, lab 1 to lab 9. Lab 1 to lab 4 is basically related to the OPIS1. Lab 5 and 6 is OPIS 2, and lab 7, 8, 9 is lab OPIS 3. And therefore, this is the course material we're gonna go. I'm gonna glance over one of them. For example, when you go OPIS 1, you're gonna have some introduction, instructions, background. This is a kind of ready videos that Professor Dan provided. You can go over and learn directly from them as needed. And equipment that you needed, only computer. And you're gonna go with different telescope that is available to take a picture and various other things and idea that I don't gonna go deep on that. But there is a background, some historical data, some procedure, how you're gonna observe, and then some way that, for example, for the observing taking the picture, observing the planet, moons, dwarf planets, deep sky object, and the moon, and also other activities on this sense. Therefore, this is a typical each of the labs are provided, and we're gonna go over many of them, but some of them we glance over. We don't need to go deep on that. We're gonna tackle on those, but eventually you learn, and many of them there is videos, learning videos embedded inside. You can go over and learn those in your spare time as needed. And if you had any question, just feel free ask John or myself on this scenario. Any question about the web assign part?
Uh, regarding the Cengage, the $65 cost, does that cover purely just astronomy course, or does that also give us access to other course material?
This only access to the OPIS material only. Therefore, but when you set up when University of the North Carolina and Chapel has set up your account, you're gonna have probably 2 weeks period free of the charge. You can go and learn, and after 2 weeks, within 2 weeks, you need to pay it 65. They will give you some link that you have to pay it, and then you pay the 65 and you're going to have it for entire course activities, and you can save the material and learn as you go through the different labs on OPIS 1, 2, and 3.
Yeah,
And
the materials like the Skynet and other accounts you're going to get, what we've seen so far is those don't go away. So I remember, I know Rui and others had participated last spring, and she had her still this fall and could access. And I had some from actually my firm was a year and a half ago, and they're still accessible. So that part will never go away. Go ahead. I'm sorry.
regarding the Opus courses, will these be running concurrently or consecutively?
That's gonna be OPIS 1 and 2 gonna be consequence. It means that from OPIS 1 and 2 is on Thursday. Therefore, we're gonna start the OPIS 1 on the Thursday. Then after around 6 or 7 weeks, after OPIS 1 is finished, we're gonna go to OPIS 2. It means that, for example, in here, we're gonna start from lab 1 on Thursday, and then we go not this Thursday, next Thursday, because this Thursday is gonna be orientation, and then we're gonna go lab 1, 2, 3, 4, 5 till December on the Thursday. But we're gonna start next Tuesday. We're gonna start with OPIS 3 Lab 7. Therefore, Lab 7 gonna be concur with the other offices, but OPIS 1 and 2 gonna be back to back each other. Therefore, we set up this one because they are totally related to each other, and OPIS Lab 1 to 6 mostly visual observation, and Lab 7 to 9 is more advanced for the radio astronomy.
All
Yeah,
right.
did you get your response, or you had any other question? I get your response correctly, or what I hope I get correctly responded as your question is that you mean is that the idea is that we just developed it in Tuesday and Thursday to make sure that we tackle visual and radio separately. On the Tuesday, we're gonna tackle the radio. It's gonna be independent than the visual. We don't need it to learn this 1 to 5 or 6 to know that, but because you're gonna have eventually when we start lab 7, you're gonna start lab 1 also. It's gonna help each other. It's gonna be helpful about you learn about visual and radio observation.
Okay, thank you.
You're welcome. Therefore, the first one is WebAssign that I said for after you set up the account. Probably first 2 weeks gonna be free of the charge, but after that the system that is Cengage created that one provide a login requirement for the payment, and then when you pay it, you're gonna have access to the WebAssign by entire end of the course, and you can have save them many of the material as you need it. during the time without any cost. Therefore, that's going to be opportunity for you that you collect and take a measurement, and also whatever you think is good, just take a kind of note sheet for yourself, copy and paste in your Word or any other tools. Then you can have it for later access as well. The videos within this course is going to be available from YouTube as well. Then you can look through it, that we're going to share you on the course. But most of the courses, although the $65 is mainly because the company that created this course, they had some costs associated with them. They want to reimburse that kind of cost, that is administration of this, and that's a minimum charges. It is not considered as a kind of tuition, but just access for the data collection, and also probably when you take a picture, sending to the website, and they give you back a mark. For example, from 100 you get 89 or 99 or 90. That kind of marking and grading also included on this kind of administration. And this is, we don't have to treat it, this one, like a grade course that you're gonna fail or you're gonna pass. But the idea is that you learn. It doesn't mean that you're gonna pass it if you get grade 100 or grade about 70. But this is kind of grade is assigned for you to learn how to engage with the various hands-on activity and submit the material on the course. Therefore, keep in mind this grade is not pass or fail grade, but this is kind of a learning measurement for everybody. It's not accounted for the grading or passing or fail. Next item is the Skynet. I go to in the Skynet beginning. On the Skynet, probably, let me go from the Google. On the Google or any Mac that you have, you say Skynet login. When you click Skynet login, it's called skynet.unc.edu. This is a program that is developed in University of the North Carolina in Chapel Hill for this purpose. As you open this website, you can log in on that with your email account, and based on that, you have various activity you can do that here that we're gonna go over the course of the material. Mainly here, my observatory, this is kind of observatory that is available. You're gonna take a picture, optical or radio. OPIS 1 and 2 is optical, OPIS 3 is radio. And the telescope site, this is a various telescope site that you have. This is the American Public Universities Observatory, Athabasca University, another Athabasca #2, Perth University in Australia, and Cerro Tololo in Chile. And this is the Demo East and Demo West, and Dark Sky Observatory, Fan Monte, some of them in the United States, some of them in Canada, some of them in Poland, some of them in Australia, some of them in Chile. And that's, for example, Meckering Observatory also in the Australia. Moorhead is located in Chapel Hill, and Montana Learning Center. Green Bank Observatory. This Green Bank Observatory is radio observatory that we're going to use for the OPIS3. And the other ones is the Rodney Astrophysical Observatory, Rankin, Siding, Fort, and you see plenty of the observatory. You can have take a picture within this set. This is Skynet, they call it, let me see it here, go back here, home. This observe the night sky, this kind of Skynet University. If you go to the Skynet University in the Google, just kind of information, it goes back again to the same thing, because this is a Skynet Robotic Telescope Network, a collection of the many telescope sites across the globe. They connected to each other, and you can take a picture. And then when you take a picture, it's going to save it for you in your account. You can access it anytime after the class also. For example, if you don't close your account, after 6 months, a year, or 2 years, or 3 years, you can access to your data as well. And you can have access to the other data that other observer it taking as well. Right now, probably there is many thousands of the people has many 100,000 pictures available on this system that you can have access and use it as needed. And therefore, this is a telescope site that we're going to go over, and this is the optical observation. If we go to the optical observation, this is a picture that I have taken. It's going to show you, but when you log in, is for you going to be empty at the beginning. And this is a picture that I took it from the telescope that is highlighted here. And this is a PGS. I took it on June 2025. And this is, let's say, this is a very nice picture. It's very cool that you can have it and you save it in your account. And this account is saved in my account, but everybody else can access to that as well. Therefore, it's not, and each observation gonna have some code on it. This is a number of the observatory. It's about 12,740,126. This is the number of the observation that done on the Skynet system. Therefore, this is a very good opportunity for everybody that they use it. And in addition of that, there is another program exists. Here you see it, Afterglow. When you click on that, you go to another program. They call it Afterglow. Afterglow, the Skynet UNC EDU workbench. And this Afterglow is provided post-processing. For example, if I wanna take some picture of that I took it previously, I go my data. We're gonna go over. I'm gonna show only glance over. For example, this is I go with one of the. Let me see one of the pictures that I took in before. For example, this is 101, and then I take. I open up, and this is a picture that you're taking. And then right now you see it fuzzy and kind of very noisy, but we're gonna look through it and detail it how we can process it and make it better, like a faint or bright object. Let me go over again at default setting, and then we're gonna look through it. Therefore, Afterglow workbench, the Skynet that you had, sorry, the Skynet that you had to take a picture, radio or optical. Afterglow is for the post-processing that I showed you here. And another program that we had, this is also online, Astromancer Skynet UNC EDU. This is for the taking the graph to give the data and gives you the graph, different graphs that using to astronomy. And that's also a very good tool that we're gonna go and look through how we tackle those as well. And I think this is the main item that we have, WebAssembly, Skynet, uh, work, Afterglow Workbench, Astromancer for the graphing. And this is the kind of tools that we have. And all of them you see here, this curve for the OPIS, all of them is created for the OPIS that on this course is available. Any question on this tools so far? Rohan?
These tools, do you have to access these through the Skynet tool?
No, no, you can have it. It's free. You can go, for example, you can try right now as you are at the
Mhm.
computer. Let me put it in the chat to see if you can go and look through it. It's free of the free access. This is Afterglow,
I went ahead
and
and
this
dropped in Skynet
no,
for you.
sorry, Astromancer.
Yeah, thank you.
Astromancer. You have to log in first, but after login, you have access free of the charge for those.
So Ruan has some questions about the login as far as the key, Quark's key for Cengage. And then will he have a login account already, or does he have to establish that? I'm trying to remember how we did that in the past.
Your question, me, John?
Yeah, boss. So he'll need a login for Skynet to log in, won't
Okay,
he?
yeah, I will show you that one. Oh, perfect. Let me go over, show you the login. As you are here, let me go uh, in here. Let me go log out. Okay, I'm gonna show you from the beginning. You just say Skynet login, uh, click, and you find there might be some other Skynet available. For example, this is a fake Skynet, or you may find something else. But whatever is correct is this is a Skynet.unc.edu. This is the actual website. You click on that, and when you come here, you just go to the login. And here I have a login account that created. But because you don't have it, you just um, start here. Uh, Let me see if you don't have it. Assume I don't have it. I'm starting from scratch. And then you have to create an account here. Therefore, you have to, let me see, where is the account?
Sir, you sent us an email with like an activation key. I was able to get into Skynet. I was curious about the Cengage software.
Yeah, yeah. But Cengage, they're gonna send you activation. Yeah, they're gonna introduce you activation. But you're right. For the Skynet, no. You able to log in on the Skynet?
Yes, I was able to log in.
Okay, very good. And also, I think similar way to the workbench and the what to call it, Astromancer, the same way. Astromancer, I think you don't need it to have any account. I think, or you can create an account, but it's free. You can have it easily without having any account. But you can go for the Astromancer, for example. I go my here, and oh, you can go after Glow separately. You can go through the Astro Skynet. The advantage of the going to Skynet is that when you go to the Skynet, you have an option to choose the same user and password that you have on the Skynet to use it for Afterglow. That save a lot of information. You don't need to have separate login for Afterglow and a Skynet. If you have for a Skynet, you use it, click on that mark here and use it the same login that you have in Skynet. You can go directly Afterglow. Then you're going to have one set of the user ID and password for Afterglow and save a lot of headache for you to have different names and passwords.
All right.
Okay. And that's a cool feature that they have it because most of the time we just tackling from here to the afterglow. We take a picture here, we go here to see post-processing the data and pictures. And that's going to be good and useful for us. Next item, I'm going to go um, um, just glance over to curriculum of the INET. This is a kind of, if you go to the, I will share this one also with you on the chat. Uh, is, this is a curriculum that we have, is actually Professor Dan created for the course that is available. You can look through over. This is, for example, OPIS, although they call it undergraduate and advanced high school, it means that you can learn it easily on the any years of the high school, if either on senior or second grade on high school, second level program or third, you can easily use it. And this one is actually founded by a National Science Foundation, uh, and the professor created that one. The idea is that here, if you look through it in this program, in this picture here, it is based on the distance ladder. It means that we are here, assuming we are located on this point, and the nearest object to us is the Earth. We're living on the Earth. And after the Earth, we just measuring the nearby object, like diameter of the Earth orbit around the Sun, or uh, measuring the variable star for the Milky Way. Therefore, for example, for the measuring the data distance from Pluto to us, we can use this technique. For measuring the nearest uh, star for us, Alpha Centauri, is about 1.3 parsec. We can use this system. We call it stellar parallax. We're gonna go. This is the kind of terminology that we're gonna use: parallax and variable stars, Cepheid layers, and type Y1a supernova and Hubble law. This Hubble law mainly probably gonna be on OPIS 3, but the remaining gonna be on OPIS 1 and 2. On OPIS 1, we're gonna go on this three objects. I mean here first, second, third, and fourth. And 5 and 6, we're gonna go to the Cepheids and type 1 supernova. And we're gonna measure how astronomers take the measurements from nearest objects to the faraway distant celestial objects. And and you're gonna see it in future session how it is measurement is accurate. For example, it is gonna be amazing. For example, myself, I measured the distance from Earth to the Jupiter in less than a 5% error. And that is amazing that you can do it with this kind of quick and fantastic tools, measure the distances by that much accuracy. And same thing to the other galaxies and similar object on the universe as well. This one is actually belongs to the very big pyramid of the observation. The basic is the facility that you have. Facility is Skynet. Trump telescopes is the main, several telescopes is located on Chile, on the Andes mountain, radio telescope and afterglow. That's the one that I informed to you, the various telescopes and the tools that we have. This is our main tool for the courses, both OPIS and MWU. And Astro 101, the basic astronomical course on the university and also advanced high school. We call it OPIS, or Place on the Space. And this too is introductory for the astronomy. And then on the MWU, we're gonna go on the next level. And this one that you see it on the pink and above that, this is a graduate school on the higher school and PhD courses that we're not gonna reach there. But we're gonna tackle most of the main introductory course and MWU, a little bit advanced courses on research as well. That's going to be fantastic that you can learn with basic knowledge of the higher school. And that's a very good tool that Dr. Reinhardt created by this tool. And here, for example, the picture that you may see it here on the here, how to assign the color, and this is a radio telescope expand, how they show the activity of the school. And this shows the different various tools that this curriculum created. And you can easily, by the small tools in the computer, you can create scientific curves and data and publish the actual astronomical data that you needed to have. And this shows the educators and the training course that has on the Green Bank Observatory that every year they created. And this is a picture of the Moorhead Observatory on the Chapel Hill. That is one of the observatories that we used for this case. Therefore, this website is basically gives us some introductory information about the course, how you're going to tackle different things. And you may have here many different other things that you can look through it. For example, project intro, outro, or many different tools that is available you can learn. And this is kind of actual idea that how this is Professor Dan, that is pictures here, and shows the history of the development of this course. It started how they developed and how the recent data information is available on this course. Any question?
Sounds good.
Very good. Okay, I'm just stop sharing here. This is the basic introductory items that I want to add it to this introductory section to give us some high level what tools that we're gonna have, except Stellarium. Also, Stellarium you don't need it to download, but I recommend to download it because it has more features based on your computer, and therefore every other things is online, and you don't need it to download anything, and you can have access for many of them for many years as long as you cannot log out and your system, because sometimes the computer programs, if you don't log in after 2 years, they will think that you just forgot it and they delete your account. But as long as you just go over and tackle every so often, you're going to have that information available. For example, myself and I, John, 1.5 year, 2 years, we have account with Skynet and WebAssign. We still have it. We don't need it to pay. We pay it one time, but after that, it's going to be available for us to use. Any question? John, do you want to add some more item?
Okay. Yeah, it's good news for me. I actually was able to get in. It was on my personal account instead of my school account, which is why I was having trouble getting logged in. So I think I'm okay there. I'll play around with that, make sure that works. Yeah, and really, everything that Boss said is spot on. As far as we will use Stellarium a lot, and the download is so much better. And I don't know if it's the same as it used to be, but if they have any add-on features, I put that in. I wouldn't add anything extra. The version you download has a lot of stuff, and if you add on some of these Sky programs, it can really load your computer down. So whenever you're uploading or using a downloaded Sky program, it's always good to start your basic program, and then if you need more stuff, just add it on slowly if you need to, because quite often that's an open community that there'll be more add-ons if you want special features. But it is a very robust program for what we're doing to do. And yeah, and everything as you said, I just repeat, Skynet and Afterglow and Astromancer, those are our main programs that we'll use, I believe, this semester as we work through this. And it should be good
Yeah.
shape. All right. I think we're good. All right. Yeah, I think we've covered our basis. I was checking through my notes. I always try to think ahead for make sure we've covered everything, and I think we're in real good shape. Now, the plan on Thursday is to have a very similar orientation session, I believe. So, Rowan, you're in good shape. It's basically a repeat of today. Is that correct, boss, for the most part?
Yeah, it's gonna be repeated. We're gonna first. I decided to just give some overview of the items that we have, tools that we have, facility that we have, because that's gonna take almost we take around 50 minutes. We go over the 45 to 50 minutes takes, and also when we know that, therefore, on the next course, we're gonna, for example, next. Tuesday, Thursday, we're gonna go lab 1, and next Tuesday we're gonna go lab 7 to active that, and hopefully by that time you have access to the course as well on the website.
Yeah. So, yep, next week we'll be going for real with Tuesday, Thursday with the courses, and it should be very exciting to see where we're going. So, I think we're pretty
Yeah.
good. Good
Yeah,
shape.
let me, I think I forgot one thing. I will tackle MWU as well to show the highlight of the MWU as well, because
I see.
we're gonna cover MWU. I forgot that one. Just give me a second. And
Yeah. I'm curious what program we're using for that. Are we using DS9 or do you know?
let me just, I think I opened the, let me see, I open it here. So, okay, let me show it to you here. I just, this one, the difference between MWU and, let me see if you can see it, make it enlarge it a little bit. Okay. Hopefully you see it very good in here. This one, OPIS, you see that on the OPIS Lab 1, Lab 2, Lab 3, and Lab 9 available. But on the, do you see the picture right now, MWU?
Nothing's showing up. No, we have no.
No, let me share it. Okay, let me do it again. Okay. Hopefully you see it at the moment.
Oh, that's weird.
Okay. Okay, here, the difference between the OPIS and MWU is that MWU is not developed yet. It is on progress of the development. Right now, both OPIS and MWU, it is taught in the almost dozens, about 30 or 40 university and schools in the United States. And therefore, probably several thousand people having this course, student and teaching assistants and professors, they do this on this line. Therefore, uh, when we go to the OPIS and also MWU, we have to keep in mind, sometimes we may find some way that make it better, the course. For example, Rohan, you may think something that might be better, you recommend for us, or I will give notice something that I can inform Dan for the making the better the course. And therefore, this is one of the key things that always Dan is uh, waiting for our feedback to see how we can make it this one better. Because this is not only written by the Dan, but it's written by the students and all the colleagues that he had on here. But the main topics that we're gonna have here, I glance over. One is the solar system at visible and invisible wavelengths. This is the one that we're gonna tackle. The visible, we look through at OPIS 1 and 2, and invisible, we call it radio wavelengths. And we're gonna see how we can color the moon on, how we're gonna see the moon on optical wavelength, and how we're gonna observe it on the radio, and also Jupiter's as well, and the planets on optical wavelengths. Some of them, some of the courses is not very well developed, but I'm trying to collect all the material from the learning that I have to make it easier. The next one, the star clusters, we're gonna go HR diagram that we're gonna see what is that and make it kind of stellar evolution. And item 3 is astrophotography. This is the basic of the astrophotography and how it's gonna tackle on the star birth cloud of the star molecules of the universe. And the main course of the colorful invisible things start from here. Here they call it colorful invisible universe. What that means? It means that the universe invisible. Where is invisible? Visible is between the red and blue, violet wavelengths that we can see the color, but infrared and um, longer wave like radio is one side, and ultraviolet and X-ray and gamma ray is on the other side. Therefore, for the observing those, because those doesn't have any color. For example, infrared or radio doesn't have a color, or gamma ray or ultraviolet doesn't have any color. How we can we have to assign a color for those to able to investigate what the color assigned to that. On the chapter 4, lab 4, we're gonna go over this one for the radio and also how we're gonna color the object on the sky. And also at the 5, we're gonna go to the explosion of the star and the star death, white dwarf, neutron star, and black holes. And these topics we're gonna rappel. And items 6 and 7, Doppler effect for the radio, and the normal and active galaxies. That is right now, this part is one of the topics on the actual graduate student on the astronomy observation. I don't know, we can go over on MW by here, but we will try to reach as much as we can to this course. But if we learn at least by this somewhere here, we will get some idea about the MW course at the core, and the remaining, I can give you the material for you. You can, after the course, you can go and use it those as needed, and you don't need it to have any payment. That is free of the charge courses that is Dr. Dan provided. And the idea is that we go as much as we can on the course, but I don't know. This is the first time that we're starting this course. We don't know how many we're gonna. My idea is that hopefully we go by end of the 5 and probably 6. But if we cannot reach by end of the December, end of the course on the 19 or 11 of the December, then remaining you can go over, or we can have some arbitrary courses sessions on the January next year, if possible. But this is a big idea about the course that we're gonna have for the, for example, I will show you module 1. This is module 1 that taking the picture for the moon. For example, one of the telescopes is take a picture only this part of the moon. Therefore, to take a whole moon, we have to take about 14 pictures back to back and attach it together to make a full size of the moon. And that's the techniques we're gonna learn. And the telescope, typical telescopes and devices that we have. And this is a filter. And this is one of the key tools that for the color astrophotography is important. As you see it, black and white, when we get it with the red filter, its picture is like that, or the green is like this, and the yellow, blue is like that. As you see it, whenever it is blue is darker, whenever green is darker, whenever red is whiter. Therefore, when you combine this together, you see the actual picture. This is a basic snapshot that shows how the astrophotography works, and we get the filters and data and how to assign them and collect them and get the picture. Therefore, this is the kind of graphs that we're going to go over next week. But this is I think this picture, it gives a better idea on the astrophotography MWU, what we're going to tackle and how we're going to use the afterglow program to assign the color for different filters output. Any question on the MW?
Now, the MWU is not on Cengage then. It'll be a separate
No, no, no.
course.
It is all of them. I'm gonna provide. Let me show it to you. The picture. This is a what to call it. This. Let's see.
Well, and there's some flexibility. We're trying to develop this course correct. Because I'll have some input actually. I was looking at number 3, the Introduction to Astrophotography and Starbirth. Because when I worked with Dr. Riebel, that's what we were using a lot of the URSA materials. I'd be
Yeah.
very interested to see if we can't offer some things there to
Uh,
help on our understanding and how this works too.
As you see it here, all of the course material, it is on the link. I'm gonna provide this one on the first session next week. I'm organizing this. This is, you see, if you look through it, you're gonna juggle and confuse which one is which one. But I try to, although he organized it 1, 2, 3, 4, 5, 6, but I'm trying to organize it in a way that have access easily for next sections, and we go over each part separately. And all of is not on the web assign, but it is click. You have to click. For example, if you click here, you come with the module data, and on the module you have different links as well to, uh, for example, data and tables and all information. Everything is written on the Google Drive that we're gonna I'm gonna share on the next week. Okay, hopefully we get a good overview of the OPIS and MWU, and we will tackle next modules next week. And hopefully you learn more, and you teach us also more items as you find out better than us, hopefully.
Yeah, it sounds like a lot of stuff, but I think, Ron, you're up for the challenge. But it's piece by piece. We put it together and we help each other, and it's not so bad. It's very manageable as we get through it. So we're at 9
Any
o'clock, so I
Yeah,
think we're
end
pretty
of the
good.
clock. Any question? No?
Few last questions. Do you know how many other people are enrolled in this course?
Right now, I think we have 10 people. I don't know, John, you have more individual assigned?
I think it's 10 right now. That's where we're at. Um, there
Yeah,
might be a couple more they'll add, but I think that's primarily what we have right now.
yeah, yeah. But we're gonna hopefully see more people, but between 10 and 20 is good number that we can have it on the course. And then that's gonna be plenty of the activities you will learn. Okay.
Right.
Hope you have a good evening and thank you for joining, Rohan, and nice to meet you. And hope we have engageful activities on this semester and we learn from each other.
Nice to meet you as well, Professor. Thank you.
Thank you. Thank
Okay,
you.
have a good
Thank
night.
you, John, for joining. Any
Yes.
final note or
Only thing I would say is, so Ron, if there is anybody else you're thinking of, it's just like you think you're going to push, they'd have to let us know right away. But we'd be interested if somebody else wants to join, if they'd be into it, have a lot of fun and willing to work a little bit at it. We'd love to have somebody else join.
Okay.
okay?
Okay.
Okay. Hopefully
Have
have
a
a
great
good
night.
evening and see you next time.
Thank you, Professor.
Thank
Mr.
you.
Taylor, I'll see you tomorrow.
See you
Thank
tomorrow.
you.
See you, Ron.
Thank you.
Good night.
Good night.